particle in a box. In this we will consider one dimensional box of width L, and we will consider that particle is remain between the walls of this box, and L is the width of this box, and we will consider that potential, this V of the particle, is infinite on the both side of the box. That is, V is 0 for x less than greater than 0 and less than L, and V is infinite for x less than equal to 0 and x is greater than equal to L. So you can say these are the boundary conditions. So we can say that particle cannot exist outside this box. So we can say that the wave function is 0 outside this box. So within the box, the Schrödinger equation wave equation is given by d2 psi dx square plus 2m h square e minus v into psi is equal to 0. So we know that for the particle within the box, we know that this potential is 0. So this equation reduces to d2 psi dx square 2m h square e psi is equal to 0, and we can rewrite it d2 psi dx square plus say k square into psi is equal to 0. Here k is 2m e upon h square under root, and the general solution of this equation of above equation is psi is equal to a sine kx plus b sine cos kx. So this is general solution of the above differential equation. So now we will solve this solution by using the boundary condition. Now using the boundary condition, we know that psi wave function is 0 at x is equal to 0, or you can say that particle will not exist at x is equal to 0. So by using this condition in say this is equation number 1, this is equation number 2, using this boundary condition, in equation 2, number 2, 0 is equal to a sine 0 plus b cos 0. So this is 0, so it comes out to be b is equal to 0. So we got the value of one constant, v is 0. Now at psi is wave function is 0, also at x is equal to L. Particle also does not exist at x is equal to L. So now the wave function solution is psi a psi k x. So now it is 0 a sine kl. So if this equation is 0, we can say a can't be equal to 0. It means that sine kl is 0, and from this we can write that kl should be equal to n pi, where n is maybe 1, 2, 3, 4, and from here we will get the k in term of n pi by L, this value. And wave function becomes psi is equal to a sine n pi by L into x. This is the wave function, or we can write this is psi n, because here we have now nth values, n is equal to 1, 2, 3, so this is psi n wave function. Now we have considered that in the from equation 1 that k we have considered it is under root 2m e by h square under root. So say this is equation number 3 and this is 4. So comparing equation 3 and 1, it is 1, yes. So in that case k is n pi by n pi by L is equal to 2me upon h square under root, and here we replace e with en. On squaring both sides, we got the expression that n square pi square by L square is equal to 2m en upon h square. On rearranging this equation, we will write here en is equal to n square pi square h square by 2m L square. So this equation shows that particle cannot have an arbitrary energy. inside the particle not have an arbitrary energy. What it has discrete energies corresponding to n is equal to 1 2 3 like this. So the energy is discrete, or the each permitted value of the energy is called the eigenvalue of the particle and constitute the energy level of the system. And wave function, that is E1, E2, E3, these are E1, E2, they will constitute the energy level of the system, and wave function corresponding to these energy levels corresponding to each eigenvalue are called eigenfunction. These are the eigenvalues. So now, in order to find the eigenfunction of a particle, we will apply the normalization condition. That is minus infinity to plus infinity psi modulo square dx is equal to 1. And we know that in this case we have the wave function or eigenfunction is a sine n pi by l into x. This is the eigenfunction, and here the limit is 0 to L because these are the dimensions of the box. So psi n square dx, or I can write this is 0 to L a square sine square n pi by L x into dx. So on integrating from 0 to L, we will get this is must be equal to 1 under the normalization condition. So by solving this integral, we will get here a square by L by 2 is equal to 1, and from here we will get the value of a is equal to comes out to 2 by under root L. And eigenfunction, we can write it psi n is equal to 2 by L sine n pi by L into x. This is the eigenfunction corresponding to each eigenstate, where n may be 1 2 3 like this. Now if we plot this wave function and the psi square of the eigenfunction within the box, one dimensional box, this is 0, this is L, this L, and in this here I will plot wave function, and in this box